Start recording. Okay, so first things first, let's go over Hurricane by going to canvas.temple.edu. Right? So, let's see. Problem solving over here. Click on this. Modules. Hawaiian pronunciation, not the Hawaiian pronunciation. So what we go over today will also be relevant for the Hawaiian pronunciation. Okay, again, we're going to just download the starter files. We're going to move them to, I'll move them to the desktop, right? Again, you know, it's if you try to demo this to me and it's not in the starter files folder and like, you know, you're not sure why it's not working, it's a very good indication that you didn't actually do the work yourself to me. So make sure you do the work yourself and figure out how this works, right? For this first stuff, we ignore what goes on in here. Okay, the code to animate Irma is very, yes. What? I don't mind, it's just when you go to demo it. That's the important thing. When you demo it, you gotta make sure it's in the right place. Okay? So okay. Your code to animate Irma here. So first off, to remind you, T over here is our turtle, okay? So there's a couple things we need to do. First thing you're gonna wanna do is, you know, is read the file, right? That's task number one. We are going to read the file. We're going to open the file. Okay. Then we're going to read each line in a using a for loop. Except for the first line. Why except for the first line? The first line has legend. So you might want to use read lines to store it in a list and then discard the first one. You know, that's generally the easiest way to do it, but you want to read each line of the file. We need to then split. So once you've got that, and you can test this by printing out. So, and again, each of these portions you should test out by like printing out something relevant or doing something relevant with the turtle. Okay, so this one, if you're reading each line, you should print out that line to make sure that you're reading the file. Okay, the worst thing you can do is not get it working and move on to the next part. That's how you end up with a bunch of messy spaghetti in your code. Okay, nobody likes that. So read each line using for loop. Once you've got each line, we need to break it up into its component parts. Break up the line using the split function, right? We use the split function to break up the line on commas. So you're given each line. So what you do is you read each line, and then what you do is you break up the line into those fields. Okay. Retrieve longitude and latitude, which again you test that by printing out the longitude and latitude and only the longitude and latitude, rather than printing out the entire thing, okay? Next step. Make turtle go to longitude and latitude, right? And there we just simply use the go to function, okay? We use the go-to function to move the turtle to the appropriate longitude and latitude. Make sense? So you read it, you read the line, you retrieve the longitude and latitude, you've printed out the longitude and latitude, now you go back to your code, and you check your code, and you go, okay, now let me ingest this instead of printing out the file, now let's actually get this turtle moving. once that is working, you should be able to see the turtle move across the screen. If it looks like it's it's supposed to be working, you don't get any errors, the turtle's going to a location, but you don't see the turtle, you probably made the same mistake I did when I first started this program, which is you confused your longitude and your latitude with your x and your y. Flip which one is the x and which one is the y, and you should be able to see it animate. That's most of your program done right there. Next is that we need to figure out the word, and the next part is figure out the category. Okay? How do you know what category storm a hurricane is? Yes. Based on the wind speed. And how did you figure that out? Sorry? No, I mean not the wind speed. How did you know that it's wind speed that determines the category? You Googled it, which is what I expected everybody to do. That's how you do. That's how you figure it out. The wind speed. So you use the wind speed to figure it out. Basically, just you have to create an if-else block. So once your turtle is moving into the correct location, then and only then should you worry about the wind speed. You use the wind. Basically, you say if the wind speed is between this color, do one color and one thickness. Otherwise, if the wind speed is this, do another color, another thickness. And figure out the category off the wind speed and modify how the turtle draws. By the way, even though this comes after the go-to, in the instructions that I'm leaving out for you, you should put that before the go-to. Right? Yes?
Now, for the go-to position, do we need a neutral position for the turtle to go to first?
Nope, you just go straight to that position. No need to do a neutral position or anything like that. You just go to the first position. That's fine. Okay. Next is, once that's done, figure out how to write the number of the category. You might want to do that with, I believe it's the write function. I don't use it that much, but you check your turtle documentation, and that should be able to get the turtle to write whatever number on there. Once you're done with that, the entire program's done. Make sense? Right? So again, what you're doing is you're reading if you're starting from scratch, what you should do is read each file. So read the file, not each file. Read the file. Go through each line. Print out the latitude and longitude for that line. And again, the way you do that is you use split to break up the line. Once the line's been split up, retrieve the latitude and longitude. Once you're done for this first part, don't worry about the fact that we're working in a turtle program. Right now, you're just making sure that you're able to correctly parse the file. The turtle stuff is its own thing, right? Once you have this stuff, then you can start using it to move the turtle. That's what this is. Then once you know the turtle is working and moving appropriately, only then should you continue on to that if-else block, right? This program becomes extremely tenable once we move from trying to do it all at once to trying to do little progressive parts to build up, right? We want to progressively build up parts, okay, to this program. Okay. Any questions on this? Let's see. I'll go ahead and dump this into the Discord in case you're just madly scrambling this. But again, you'll be able to reference it here for this. Okay. And if you're using a Mac, right, you might have some difficulties that's okay. I think you just resolve the difficulties by putting a turtle.done over here at the end to make it not disappear. Again, if it shows up as a white screen, like it flickers in white screen, that's just simply a way that the turtle library is working because you're just showing the image and then you're done with it, right? So don't worry about that. Focus on this stuff first. As long as you're not getting any errors, it's going to work in the end, okay? So first, open up the file and read each file. Once you're here, you know you're not going to get any file not found exceptions, okay? All right. So I also got some emails on Sunday, this past Sunday, that I can only assume were draft emails that hadn't been completely finished because they contained the magic phrase, I didn't know I have to demo my finals. So to all those students who sent that, I highly recommend you go back, read the syllabus, and finish that email and properly review and revise it so that you can send it to me properly. Hint, hint, nudge, nudge. So anyway, so let's go ahead and get on to today's topic, which is dictionaries. Dictionaries are known by many different many different things in many different programming languages. In Lua, they're associative. I think there's is it Lua? Well, in JavaScript, I think they're associative arrays. In other programming languages like Python, they are known as dictionaries. In Java, they're known as hash maps. Sometimes they're referred to as just maps or hash tables. The hash comes from basically the technique called hashing. If you're interested in the computer theory, what makes them so fascinating is that they have a constant time lookup speed for things in there, meaning that no matter how big it is, you can instantly retrieve the thing that you've stored in them. How it does so is something reserved for 2168. It is a very, very cool feature of programming languages. The dictionary is, but right here we're going to call it a dictionary. We used L for list over here, right? We created a new list off a lot of the times saying L is equal to open bracket, close bracket, and that would create an ordered list. Dictionaries really don't, and basically we would say, hey, A is at index 0, B is at index 2, and C is at index 3, right? And then I could, index 2. A is at index 0, B is at index 1, C is at index 2. And then if I wanted to add something to index 3, I would do L.append to add to the end of it, right? These were, mutable, and I could just simply add it. And the important thing about lists is that lists have an order. They have a first thing and a last thing. Whether or not you care about it being in a certain order depends on the case, right? For instance, like if you're making a shopping list, you really don't care about the order too much, right? But if you're, making a recipe, then of course you care about the order. Again, it all depends on context for a list. Dictionaries have 3 use cases, but one of the distinguishing features about them is that that once you decide to use a dictionary, you got to throw any semblance of keeping things in order out the window. There is no order to a dictionary. You just do things. Okay? Python will try to keep things in the order that you inserted them into the dictionary, but honestly, never assume that's going to be the case. So the dictionary is declared a lot like an empty dictionary is declared a lot like an empty list. We're going to use D for dictionary. And rather than doing the brackets, we're going to do this. We're going to press the same key, but hold down Shift to get the curly braces. That's what we call these things. Pretty much nobody else uses these but programmers. This is what curly braces are used for in Python. In Java, we use curly braces to kind of denote scope, but we don't have to do that in Python because we're using white space for scope. So we use these to denote an empty dictionary. Dictionaries store arbitrary key value pairings. This is I know that was a very abstract sentence. So basically what that means is that I can make up the indexes to be whatever I want. Okay? So I can say D is equal to, I can say D of 4 is equal to, D of 4 just like that, is equal to apple. Okay, and I'm going to use, an integer and string to begin with. Okay, and that stores that no problem. The way it looks once it is stored is that we just can simply print out D and see this binding over here. And it reads like this, 4:apple. What that means is that the key is that we've got a key value pair. Okay? If you remember like the really abstract definitions of a function in algebra, this is what we're doing. We're creating a mapping, a one-directional mapping. Essentially, 4 goes to apple. Okay? Okay? So if I ask D for 4, it's going to give me apple. Okay? If I do D5 is equal to banana, that's going to create a new binding between 5 and banana in the dictionary between 5 and banana. 5 is what we formally call the key, banana is what we call the value. So the key 4 gives us an apple, the key 5 will give us a banana. So if I go D and ask for 4, it's going to give me apple. D5 is going to give me banana. So a couple things to note here. D3 is going to give me a key error, meaning that it's saying there is no key 3. There's only the keys 4 and 5. Those are the only ones I declared, right? Okay? And again, I can say D10 is equal to cucumber, right? Cucumber. D, apple, banana, cucumber, right? So now if I say D6, it's not going to give me that. Again, it's going to give me that error saying, hey, it doesn't matter what the keys are. They're arbitrary. So just because there's a 4 or 5 and a 10, there isn't automatically going to be stuff generated between 5 and 10. The only thing that exists in a dictionary is what we put into it. Okay? And again, it is a key value mapping. Okay? So this becomes, and now it becomes a lot easier once you see this, or a lot less scary once we see this, I feel. When I say D of apple, D apple gives me also a key error. There is no key called apple, right? It's a one-directional mapping. Make sense? Meaning that it's key to value. You can't go backwards. Okay? But there's nothing that stops me from saying key no is equal to durian, which if you know the smell, you understand why. So when I say that the key can be anything. The key can be anything, and the value can also be anything. We're just creating a binding between. Basically, we're doing word association for the computer. Just random arbitrary words, and then it says, basically, the phrase, if when I say frog, you jump, that phrase? That's what we're creating these arbitrary mappings like that between the computer. Between words for the computer. Why? Why do we do this? Okay, there's a few reasons as to why we would do this. First off, key value mapping is just very strong on its own as like an application. For instance, take a look at basically logging on to Amazon. Okay? Everybody needs a unique ID of some kind, which is your email address typically because your email address will be unique. Your name won't be unique. Okay? Mine certainly isn't, believe it or not. When I was in middle school, I was asked, hey, are you related to another Andrew Rosen who just graduated from from middle school? And I'm like, no. So my name, your name is not unique. My name is not unique. So we can't use that. Same with your address. If you're living with your family, you know very well your address is not unique, right? Okay? But what's going to be unique is your email. So we can use that email as the key, and the value is basically all the information about you. Okay, and that can be, and that's how I can, the computer knows to look at that specifically, or the server knows to look at that information and serve that to you specifically. Okay, because there's a key value pairing there. Okay, the other two more abstract uses for this are counting and categorization. We can count arbitrary things using a dictionary very easily. That would be a real pain to do with just a list. And then we can also categorize things. Categorizing we don't really use too much here, okay, in this class. But I do use it in 2168 for one of the assignments. So categorization doesn't really get used too much. Categorization would be basically saying, would be something like D, awesome, and then I would have a list of, then I would have a list as the value of all the awesome things, right? That's categorization, and it's useful for basically trying to say, okay, which category is bigger, because I want to maybe select that as my options as opposed to something else. Okay. What do I mean by counting? So let's go ahead. Let's go ahead and go back to, let's see, documents, GitHub. I'm going to go to my classroom stuff, Intro to Programming in Python, and what we'll do is I will look at let's see, we should have stuff in here, right? So we have okay. So I have this from last semester, open. Okay. So what I've done here is I've went ahead and downloaded the Dracula.txt file from Bram Stoker's Dracula from Project Gutenberg. I could do the same for Hamlet, honestly, and I will do the same, okay? So let's go with and call this Hamlet count .py and save as type. No extension there, so it's going to be a Python file. Okay, so now we've got a Python file called Hamlet count, and we're going to open up and read it, okay? And what we can do is we can start playing around by counting how many the ways, how much like each letter occurs in the Hamlet file, okay? Like, what are the counts of each individual letter, okay? So first, let's go and review how to open that. So open, and I'm going to do Hamlet.txt, okay? I'm going to open it in read mode. And again, just for the purposes of only these things that come from Project Gutenberg, I'm going to use encoding is, let's see, I believe it's encoding is equal to UTF-8. UTF-8. You don't need this, you almost never need this. It's just because of the way Project Gutenberg in Windows works. That's all, okay? And I'm going to call this the file, because that's what it is it is the file object. Okay, and what I can do is I can just read through this very easily. I love reading through files by using for loop. For line in the file, right? So I'm going to just go ahead and do something basic to prove that it's working without printing it out, because if I print it out, it's going to take forever, right? So instead, what I'll do is I'll create a number called numLines, and we're just simply going to count the number of lines in the file. This is a very straightforward operation. How do I count the number of lines in a file? I read a line, and then I increment this counter by 1. Make sense? Right? Number of lines is equal to 0. For each line, I'm reading it now, increment the number of lines in that. And then it does nothing, of course, or it does something, but it doesn't actually tell me anything interesting, because guess what? I didn't print anything. So print line. You'll notice now that I'm using VS Code. That's just, again, just personal preference at this point. Don't be too scared about the fact you can do everything I'm doing in idle. It's just easier for me, quicker for me to operate in VS Code sometimes. I don't want to print line. I want to print num lines, right? Remember, I'm not infallible. Okay, and so it says that Hamlet has 7,084 lines in the file. Okay. Okay, so now let's go ahead and count the individual occurrence of each letters. How many, say we wanted to figure out let's actually make that pretty easy for us. Let's just start easy. Let's go ahead and maybe do num z's, okay? Just to kind of build up to our rationale for why. Instead of the number of lines, let's go ahead and count the number of times the letter Z occurs in Hamlet, okay? Z is a very uncommon letter, but does appear, I'm sure, in Hamlet. So what we're going to do is we've got a few ways to do this. I'm going to go basically maybe the most annoyingly brute force way possible, which is I'm going to say, okay, for every line in the text, for every character in the line, right? For every character in the line, if the car equals Z or car equals capital Z, okay, num z's plus equals 1, okay? So z's, really? Oh, num lines, right? Didn't change what I was printing out. So excited to move forward, right? So 126 z's in Hamlet. Now, we could use this to figure out how many of each character there were by some maybe 5 to 10 minutes worth of copying and pasting, right? Where I just simply say, okay, num A's, and then basically copying another if statement, right? Block, and basically say if A or A, everybody kind of gets the point. I could do that 26 times. It wouldn't take me too long. Be very annoying. It wouldn't take me too long, but it would also make my code look like a mess. Now, there's a more organized way to do that with a list, okay? Which involves some nice tricky math to do. But what you could do is that basically you could say, okay, I have this list. Okay, I'm going to say called counts, and it's going to contain 26 zeros, one for each letter, right? Everybody clear on why I did 0 times 26 there? Right? And what I could do is I could let each index kind of represent, right, a different counting. Don't worry about this part because I'm about to justify its existence and then say it's crap. So, so we could use index 0 for A, use index 0 for B, use index 1 for B, right? Index 2 for C, right? Each one gets a letter, right? Each index for each letter of the alphabet. Make sense? Now, we could, of course, have this 26-letter loop, but that's terrible, okay? Instead, what we could do is use some fancy math here, which I'm going to do very quickly and barely explain because it's not really important. What I would do over here I would do if F letter dot, car dot lower in A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z, right? I would do all that. Make the letter lowercase if it's one of the alphabetic letters, which I could have done a lot quicker, but hey, I was already typing it out. Okay, if it's that, then index is equal to, rather than doing this as one messy line, I'll say index is equal to car, ord, board the car, subtract 97 from it, and then turn that back into a car, and then, sorry, index is equal to this, and then I don't need to do anything else with that. I just need to get that, and then index, counts plus equal the counts of index plus equals 1. What in the world did I just do there? Well, lowercase a has the numerical value built into ASCII as 97. B is 98. I mean, I don't know that. I think that's what it is off the top of my head. I really should be careful and do this instead, which says get the numerical value of my character, which is going to be one of these things. Okay? And again, I'll lowercase it because otherwise it's going to break. Get the numerical value of one of these things, subtract the letter A from it. A minus A would be 0, B minus A would be 1, C minus A would be 2, so on and so forth. That way I don't have to have a bunch of if-else statements. That requires knowing some nasty arithmetic, which we could avoid using dictionaries, which we'll get into in a second. But we can see it's possible just with lists to go through every letter, check if it's lowercase, and then, check if it's a letter. Go through every glyph, check if it's a letter, and then increment it. Okay. Now let's go ahead and change the problem to something that's going to necessitate the use of something more powerful than a list. What are the 10 most common words in Hamlet? Can't figure that out with a list. There's no way to figure that out with a list. Okay. The 10 commonest words in Hamlet, can't figure that out with a list, because we'd have to keep track of every individual word, because just because a word was once the most frequent word doesn't mean it will remain the most frequent word for the entirety of the play, right? So instead what we need to do is use a dictionary. Now we're going to do this by first looking at solving this original problem, counting each letter using a dictionary. Okay? So let's go and step back and instead use this easier problem to do the dictionary stuff. I'm going to go ahead and copy that string of alphabetic characters, and I'm just going to call it alpha over here, so I can reference it later. Make sense? And instead, my counts, instead of being this, I'm going to make my counts a dictionary. This is going to be basically my counts. I'm going to call it letter counts here. Make sense? And then everything else over here, it's just not going to exist anymore. Okay? We don't need it anymore. I mean, this is a recording, actually, so I really don't need it anymore. So if you needed that, rewind back. Wasn't important then anyway. We're going to delete these things because these are also not important anymore. And let's go ahead and print letter counts out at the end. Okay? Now, what do we have to do to use a dictionary? So what we're going to do is that we are going to look for every line in the file, check every letter. If letter in alpha, again, let's go ahead and actually make this a bit easier for us. It's not car. Let's go ahead and change this to letter because I'm using that automatically. Letter is equal to letter dot lower. So this just simply puts in lowercase for me, right? Because easier to keep track of lowercase characters like that. If it's an alphabetic character, right? So if it's one of these characters, I want to keep track of it. So our letter counts off starts out as basically in a completely empty state with nothing inside of it. So there's two cases. So as we're going through this loop, there's essentially two cases when we want to increment our count of a letter, right? When we see a letter, we want to say, okay, the number of times I've seen it is equal to the number of times I've seen it plus 1, right? So if I've seen it 7 times before and I see this letter again, now I've seen it 8 times, right? That makes sense to everybody how that's going to work? So what we do is that we're going to go through, check each letter. Every time I see the letter, I'm going to increment the number of times I've seen it. But initially, it's empty. So what I'm going to say is I'm going to ask the question, have I seen this letter before? Is this a letter I've seen before? And we do that by saying, if letter in letter counts. Basically, that just asks if it's a key. Is this a key yet? Is this something I'm keeping track of yet? If you want to if you're being paranoid and want to be really specific, you use the keys function to make sure that you're getting, to make sure you're looking at the keys. But if letter in letter counts, basically, is this a letter I've seen? Is this a letter I've seen before? We can then change this to if letter not in letter counts. So if this is a letter I haven't seen yet. What would be the appropriate thing to do if I haven't seen a letter yet? Sorry? Add it to that. And how many times should I have seen it now? Once. Exactly right. So the way we do that is fairly straightforward. Letter counts. And the way I like to read this is letter counts for that particular letter is now equal to 1. Right? Makes sense? I haven't seen, this says, if it's not in the letter counts, well, now it is. I've seen it once. Else, that means I've seen it before. It's in there. So what I do is I say letter counts plus equals 1. In other words, increment what I've stored there by 1. Oops. That was me accidentally closing that file. Be careful not to hit Control W, because that's what that does. Okay, and there we go. We've got our count of, so over here in our output, we've got a dictionary now with the counts of letters, saying T occurs 13,978, H occurs 9,231 times, E occurs 17,530 times, P occurs 2,452 times. Okay. Any guesses as to why the order right over here has a T first and then an H? Yes? Yep, the is the first word in the file. Specifically, it's the Project Gutenberg, whatever, something or another. You know. So here, let's go ahead and review this. Open up the file for every line in it. Let's go ahead and go through every letter in that line. We're going to turn that letter into lowercase just to make it easier for us to ignore, the existence of capital letters. If it's not one of these, letters, we're going to go ahead and add it to our alphabet. If it's not one of our letters, we're going to go ahead. If it's one of the alphabetic letters, if it's not one of the letters we've seen yet, we've seen it once now by saying letter counts, bracket, letter, close bracket, to say, and the way I read that is letter counts of that letter is equal to 1. Else, the letter counts for that letter is incremented by 1, plus equals 1. So let's go ahead and see this again, but now for words. Okay? I'm going to go ahead and comment this out. And now we're going to see this work for words. To answer our original question, what are the 10 most frequent words? Now, the last part of that, figuring out which is the most frequent, by the way, it's always a pain for me, but we can do that by sorting by values, essentially. So it's annoying, but we can do that. Okay. Okay. So let's go ahead and iterate over the file again for every line in the file. We want to take our line, and what we're going to want to do is, again, I'm going to go ahead and just convert the line to lowercase, just to make the analysis a bit easier. Again, that way, a capital word and the lowercase word will be the same. Line is equal to line.lower. Okay? now I've got to figure out how in the world do I get individual words out of this file. Okay. Well, conveniently in English, right, words are separated by the glyph of a space. So we can just simply split on spaces. Yes, there's going to be weird things like punctuation to deal with. We're going to leave that for later. Okay, we're not going to worry about the punctuation right now. Punctuation is, we got to work. If we try to tackle the entire problem all at once, we're just gonna collapse from the difficulty. It's just not good. You got to break it down into manageable parts. So here, I'm just making it lowercase because I know I'm going to do that anyway. And then I need to make sure I take that. So for each line, okay, let me just grab this line. Whatsoever, you may copy it, give it away, or reuse it under the terms, right? Because this is part of the license agreement for the file. That's why it's, right, Shakespeare didn't write this bit. So here we can see it's split up by spaces, okay? So, but this is a line. This is essentially what the for loop is, one of the things a for loop is going to read. So I want to take this and change it from a single string into multiple strings, a list of strings. And that's where we use the split function, right? For a line, we're going to say, and I'm going to say words is equal to line.split. And I'm going to say, hey, I want to split on the spaces. I think if I leave it empty, it should do that. So I'm going to go, and then I'm going to go print words just to kind of confirm that I've done it. Right? So there we go. Yep. If we leave split empty, it splits on white space, which is useful. So there you go. So for each line in the file, we're going to take the line, convert to lowercase, and then we're going to take the line and we're going to split it up. We're going to let it do it automatically. Generally, when you want to split something up automatically, you want to split it up by spaces. That's a super common thing. Spaces are great for separating information. That's how we know one word begins and another word ends. We use it all the time. Okay, next. Now that we've got words, we need to work through each word individually. So for each word in our list of words, we need to do something. For right now, let's go ahead and make a note to do sanitize, as in clean, as opposed to make sane. Instead, sanitize here means clean. Sanitize word. And what do I mean by that? E.g., remove punctuation. Okay? Basically, I want to make sure I remove the punctuation. That way that a word followed by a comma is considered the same as that word with the comma. Without and with the comma should be the same. Because right now you're going to have words that have commas or quotation marks as part of them, or periods as part of them. Foundation over here. So let's see. But for right now, we're going to ignore that. Instead, we're going to assume right now that the words have already been sanitized for us, right? And the word we got, and each of the words is what we want to actually count. So here, we're going to go ahead and we're going to get rid of letter counts because we don't really need that anymore. Instead, we could use that, but I always find it better to use a variable name that makes sense, like word counts. Right? Makes sense to use that. Word counts. So for each word, if word not in word counts, right? So again, you can reverse this. You could do if we've seen it before, or if we haven't seen it before. So you could do not in, or you could do in first as your preference. It doesn't matter which one you do first. Right? Because it's two exclusive operations. Either you've seen it before or you've not seen it before. If it's not one, it has to be the other. So if I've not seen it before, then I'm going to do the same thing. I'm going to say the word counts, open bracket, for that word is equal to 1. What that does, remember in technical terms for a dictionary, is that says this word will now serve as a key, and we're going to bind it to the value of 1. So whenever I say key, whenever I say this word, I'm going to associate that with 1, and I'll give you back 1. Okay? Now, in case this didn't come across clearly because I've only implied it, it is a one-directional one-to-one mapping, meaning that we take our key maps to exactly one value. Now, many keys can have the same value, right? You can be a bunch of keys with 1, right? But, again, the keys only ever map to one value, right? You can't have a key map to multiple values. Otherwise, that'd get confusing really quickly. So, thus, when we do this, the else statement, which says, oh, I have seen it before, so I'm going to do word counts, word plus equals 1, right? Once I increment that from a 1 to a 2, that's going to replace the 1, the one that is stored with a 2. Okay? So what we've done, we've read the file, we've moved it to lowercase, we split it up, and then for every word in there, if word not in word counts, word. Sorry, we do words is equal to 1, else word counts plus equals 1. So if we've not seen it before, we've seen it once now. And if we have seen it before, I've seen it one more time. I can tell you that this will be on exam 2. Okay? Not necessarily the reading the file bit, okay? I might just simply instead I might give you a string, okay? I might give you a string and tell you to get the most common words from it, or I might give you a string and ask you to give me the most common letters, okay? Or I might give you a list and ask you to find the most common numbers, right? Something like that, right? But counting the number of times something appears with the dictionary is one of the fundamental operations we can do with the dictionary. It's doing it the bit where you're actually doing the counting is literally 4 lines long, 2 of which are if and else, And the other one sets it equal to 1, and the other one increments it. So not too bad. You can actually reduce it down to 3 by doing this. Instead, you can increment it down to 3 by doing this instead, which isn't as efficient, but it works because you're going to be doing 2 operations for every time you initialize. But you can say, if it's not in word counts, initialize it, and then always add 1 to if I've seen this word. Make sense? Because remember, I just changed that 1 to a 0. I find this, though, to be a lot more... a lot easier, and I bet you there's a built-in function in Python, just like there is in Java, that allows you to kind of do this. But this is always on the exam. We're going to see this this particular use case in Module 8, the Pig Lab, when we're looking at this keeping track of outcomes. Okay. When we're keeping track of outcomes. Now, we aren't jumping straight into this, okay? We're not jumping straight into this when we're moving with dictionaries, okay? By the way, let's go ahead and see what our results are. Instead, we're going to be going into, we're going to be using it in the more basic key value mapping to kind of just do a translation, a literal dictionary. So let's go ahead and run this. And what happens over here is that it just kind of cuts off here. So interesting to note that your console, if you're not using idle, generally has what's called a buffer, meaning that there's only so much space for it to print out stuff. And if you try to print out too much, a string that's too long, it just kind of gives up and quits on you. Now, how would we solve this problem of figuring out what the most common word is? What we would do is that the 10 most common, what we would do is that we would, that comes outside of the loop after we've got all of our counts. Okay, let's go ahead and sanitize this a bit. Word is equal to word.strip. What does strip do? Strip removes, well, documentation here says, returns a copy of the string with the leading or trailing white space removed. If cars is given and not none, remove the characters in cars instead. So instead, I can just simply do, like that, periods and comma, and now I shouldn't see any leading or trailing periods or commas. Let's go ahead. I see a Cornelius and Exunt over there. So let's go ahead and do underscore and bracket over there. And now those are gone. So that gets rid of those characters that we don't want. Here's a question mark up there. I guess we need to include question mark and exclamation points, right? But it's not going to get rid of anything that's internal, right? So for instance, like www.projectgutenberg.org, it wouldn't get rid of the dots internal. It only gets rid of like the leading and trailing ones on this. All right. Let's see, the drag count do. Now I have to do this every single time. I have to. So first off, how do I figure out now that I've got our word count, right? Let's just go ahead and print out the. I'm going to go ahead and drop this right here for later, so I don't have to go back to it. Let's just go ahead and I'm going to print out like. Let's see. I print out just the keys, right? This gives me just a list of just the keys. Not keys. So in other words, the words themselves. Oh, right. I have a bit of code I copied in and then proceeded not to use. So here, it has the keys in there. And these are just the words. Let's just simply get a small selection of the words. The first 20 words we added. Is it not? Oh, dict keys is not subscriptable. Ugh, okay, fine. I will make it subscriptable by turning it into a list. Remember, Python's great. You can tell it to do anything you want. The Project Gutenberg of Hamlet, the Prince of Denmark, is now this over here is this /UFEF. F is basically a weird begin a file character. You get that sometimes in text files. Don't worry about it too much. Really don't. So how do I basically figure out the most common one? So what I'm going to do here is I'm going to use this bit that rather than wasting your time looking it up in front of you, because I always have to look it up, but I know what it is. It is this. So actually, this might be a bit better. First, let me build up to this first, actually. So now that I've got this word count file, what I can do is I can say for every word, so once we have a dictionary, I didn't describe this bit, so I figure I should. Once you have a dictionary and it's populated, you can iterate through it like anything else, okay? For word in word counts, because I want to do this and then I want to get to going over the Hawaii file, so that you can get started on it properly when you decide to start on it. For word and word counts. Okay, what are we going to do? I'm going to print out the word, comma, and the word counts for that word. So basically, when you say for variable in dictionary, it's going to iterate over the keys. Okay? Make sense? It's going to just iterate over the keys. And so what I'm doing over here is I'm printing out the key, and then I'm getting the value associated with that key and printing it out. And there it goes. It prints out all of the keys. All the words. Like, for instance, agreement appears 18 times here. And yeah, there's still some stuff that, like semicolons, that I didn't remove, but that's okay for the purposes of this exercise, right? For word and word counts, oftentimes in my exams, if there's punctuation, I often have the sentence, don't worry about the punctuation. So, because that's not what I'm necessarily testing there. For word and word counts, print the word and the word counts. But really, again, it's not in order. If I want to order it, okay, I use this block of code right over here. Let me go ahead and change it to the variables that we have. Word counts. Okay. So let's go through this one thing at a time. First off, sorted. It takes in anything iterable. What the heck's an iterable? Things that you can iterate over. Lists are iterable. Strings are iterable. Dictionaries are iterable. An iterable basically means you can throw it as the in a for loop, right? It's the part that comes after the in a for loop. That's an iterable because for loops iterate over something. Okay? So anything that you can iterate over, we can throw sorted at it. Okay? Assuming that, the thing can be sorted. String, if you throw sorted at a, for instance, if we throw over here sorted, and I do apple, that's going to sort the string apple. A-E-L-P-P. It sorts the string in alphabetical order. Least surprising thing it could do. Okay? So word counts. So basically it takes, I've got three variables here. First off, if I just simply gave it word counts, it would sort it by the key and basically give me no difference whatsoever in my output. Okay? On the other hand, I can specify what I will call the sorting key. In other words, how I want things to be sorted. Okay? That can be like a special function to apply, and that's a function. For instance, maybe if I'm sorting strings, I want to sort it by how big. If I'm sorting something, maybe I want to sort this output by how big the strings are. What? Key is equal to len. That should work. And it does. So notice that my output is now sorted by the length of our key. Make sense so far? So you can put anything. So if you want to override the default sorting behavior, you can with key. It's very flexible. What we're going to do over here is we're going to sort by the key is going to be wordcounts.get. So word counts is our dictionary variable. But that's .get. So dictionaries have two operations for manipulating stuff in them, which is put and get. Put is putting something in, right? You're creating. That's a put is whenever we have this in there. Whenever we say word counts is equal to something. Okay? I'm going to go ahead and split this up so we can see a get in isolation. Prev count is equal to word counts dot get word is equal to prev count plus 1. So there we go. I've made that longer so we can see that this is a put. We're taking what's on the right and we're storing it on the in the left. Here, what we're doing is that this is a get, where it's on the right side, and so we're retrieving the value from it to use. So in effect, when we say word counts.get, we're saying please don't sort on the keys, please instead sort on the values. Sort on the numbers. And now if we run that, it will print out all the numbers. And we can see that the occurs 1,296 times in that file. The final thing that we had in there, which is reverse is equal to true. Instead of going from the smallest number to the biggest number, sorting goes from smallest to biggest. We're going from biggest to smallest here. And then we have a slice just to get the first 20. I'll change that to 10 so we can see the 10 most common words to answer our final question. And don't feel bad if you have to come back and look at this up. I just said I have to always look this up, and then I decided to, instead of looking it up in the middle of class, just grab what I did last semester. The, and, to, of, you, a, I, my, in, and amazingly, Hamlet is one of the top 10 words in Hamlet. Amazing, right? All right. So rather than going through this again, I'm sure you can go back and watch the overview of this because we're going to use this a lot. Rather than doing that, I'm going to make good use of your time and instead go over homework 8, which is your Hawaiian pronunciation lab. So it'd be worth it to pay attention here, okay? Because I know some of you are still working on Hurricane Tracker, but some of you aren't. And the wonderful thing about recording these things is that you can come back here, right, when you're not panicking about the Hurricane Tracker. Again, the Hurricane Tracker isn't as difficult as it seems. If you're having trouble, I highly recommend posting in the Discord. A lot of students seem to have had success of very quickly fixing errors with some of the suggestions. Okay, so the Hawaiian language is made up of only 12 valid characters. A-E-I-O-U, P-K-H-L-M-N-W. The vowels are pronounced just like the vowels would be in Japanese. A would be pronounced A, E is E, I is E, O is O, and U is U. It's what you see is what you get. There's never a difference in pronunciation unless they're paired up together, right? Okay, consonants, very easy to understand. Your consonants are just this. We have an edge case, the only difference is an edge case for W, but the edge case for W, I literally would solve that as the very last thing in the Hawaiian pronunciation lab. Ignore the W, pronouncing the W like a V until the very end, because that is very much an edge case. Okay? So P-K-H-L-M-N is pronounced by the English version of the word. And then we can do the W, and then there's different rules for the W, but again, I would handle the W as its own special thing at the end, just like we handled, February 29th as its own special thing at the very end. Okay? Your basic vowels are straightforward. A is A, as in Austin, Austin. E is E, as in egg. I is E, as in B. O is O, as in obey. And U is like the double O sound in mood. Okay? Those are our only things. Right? For instance, aloha is pronounced a-lo-ha. So what makes this... if we only had this, it would just simply be very simple to just run a for loop and go letter by letter to pronounce it. You could do that with aloha. Okay? However, that fails for one of the words I will test you on. Let's see, which is, don't save that, which is, so let's see, don't save. We've got, for the one word that I will test you on, I will always test this word, which is not keiki, but keiki. You see, when you put vowels together next to each other, like A and I, A, E, eventually people will pronounce them like A and E, but if you keep saying A, E, A, E, A, E, A, E, A, E, I, AI becomes I, just by merging those two vowel sounds together. So the other one is double vowels. A and I is I, A and E is also I. A and O is ow. A and U is ow. E and I is a. E and U is ue, or eu. I and U is u. O and I sounds like oyo. OU is ow, and ui is ui, like gooey. So again, the K key is child in Hawaiian. The IE isn't pronounced as separate vowels, but would be pronounced as A. So your output for K key would be K key. If I see, so I get two common things, which is ke, e, key. That's something I commonly see as an output. Another one I commonly see commonly see is K, E, key as outputs. Okay? So here, you're going to need something a bit more. So here, now notice I said if it was just these, I could just simply use a for loop, right, to iterate over the string, right? But if it was just these, I could use a for loop to iterate over the string. It'd be no problem whatsoever, right? But I can't. So perhaps using a for loop is the wrong tool. In fact, it is. I highly recommend using a while loop to iterate over the string, because you don't know what you'll need to iterate over. You'll need to iterate over in chunks. But where do the dictionaries come in? Well, the dictionaries come in with making it a heck of a lot easier for you to basically translate without a giant if-else block. In fact, your if-else block gets pretty small if you're using dictionaries. Okay. So it has two parts. The first part is you want to validate that the word is valid. Once you do, you check if it's a valid Hawaiian word. You warn the user and tell them to input a valid Hawaiian word. If it's a valid Hawaiian word, meaning it's made up of only characters that are from the Hawaiian alphabet, then in that case, you do the pronunciation guide. So here's example output that you can follow, right? And I highly recommend, and it should work like this. Now, where in the world does the dictionary, why am I saying this in dictionaries? Why is this in dictionaries? Okay. Well, because it becomes, using dictionaries, we have a binding here. We have a mapping. We've described a mapping. So let me go ahead and this. Hawaii guide.py. Okay. So what we want to do here with this mapping is something like this. Is it consonants or consonants? Okay, let's see. What are valid consonants, which are P, K, H, L, M, N, O, right? So we can just simply put those in a string, P, K, H, L, M, N, and W, right? I believe that's what we had. P, K, H, L, M, N, and W. Okay. So, and then we have basically two classes of pronunciation, right? And I'm going to do them as separately because that makes it a lot easier for you to do your program, which is that I would say single vowels and double vowels. Now, I'm not going to do all of them because you're capable of doing this on your own. Yes? Thank you. They're right next to each other on the keyboard inconveniently, but thank you. I completely missed that. Okay, single vowels. So remember, this is just considering things as they're pronounced singly, or pronounced as like just by themselves. So if we see the letter A, that should go to the sound ah, just like that, right? So what does this do? This says, rather than doing it like this, where I'm manually like saying, A is equal to ah, that takes up a lot of space. Instead, I'm doing it right here. A is ah, E, the letter E is colon eh. So we use the colon to basically separate the key value pair, and each pair is separated by a comma. So here this is A to ah, E to eh. So and you can do the other three very easily on your own. And separately we're gonna have a dictionary for the double vowel. I haven't explained why yet. Okay? So for instance, A and I together make the I sound, right? So def, validate word, pass, def, def, pronounce. I know a lot of times it's difficult to get started on these things by figuring it out how to do this and how to organize this. Remember, pass basically means fill this in later, please, because otherwise it's gonna crash without something indented into it. Def, main loop. Okay. Pass. The main loop is, again, the least important part is kind of the least important part of the program, even though it's called the main loop, because most of the work is done in validate and pronounce. What the main loop does is that it asks the user for input and basically checks it. If it's not valid, it keeps asking to validate it. Otherwise, it passes it to pronounce, gets the pronunciation, and gives it back to the user. The main loop is basically the input-output communication. Work on that last, because it's the easiest portion of it, and once you get the other two portions of that working, it's a lot easier. You use these two to easily build main loop. Now, validate and pronounce can be done separately and tested separately. Validate just simply returns true or false, right? It tells me whether or not it's a valid word. This is completely separate than pronunciation. To test pronunciation, because you're going to validate every word, you can just assume every word you get in pronounce is going to be a valid Hawaiian word. Validate is very easy. Just make sure none of the characters are illegal characters. Or rather, I should say, the characters are only, the valid character, the one of the 12 Hawaiian characters, plus apostrophes, right? Apostrophes are part of the Hawaiian words. These are, you're going to need an if statement in there as part of it. But you're going to need like a for loop as well, or you're going to need something like that. Anyway, most of your work will be in pronounce. Given what's a valid Hawaiian word, give me the pronunciation for it. And this is where those dictionaries come in. Okay? To give a pronunciation, it's actually fairly straightforward what we're doing is that we are getting, for some parts it's very straightforward, is what I'm trying to say. For, aloha. We pronounce this as A, and then anytime we get a consonant, that's simply to pronounce the consonant, except for the edge case of a W, which I said to tackle very last. You would just simply, if you see a consonant in your input string, you just simply put that same consonant into your output string, right? That's why we have in the consonants over here, it's just a list of strings. If it's the valid ones, you just output it, right? If it's a single vowel, right? If it's a single vowel, we look at the single vowel and we translate it and we get the pronunciation. for instance, we saw A here, so we went up to here to the single vowel dictionary, and we got ah. Then we got the L, so we did lo, and then we did L for L, and then the O will become like that. Once we do a vowel sound, that's going to be the end of a syllable. So for the end of, once we're done with a syllable, we just output a dash. So that's how we know to put a dash. Anytime we put the pronunciation of a vowel or vowel pair, we just add a dash to the end. Make sense? And finally, with that A, we would do that. Or we would just simply go back to the single vowels and do that. Now, the easiest way to do that is to not worry about like I said, after every vowel character, you're going to get a dash. So you'll get something, if you follow that direction, you're going to get something like that. Don't panic about that. That's great because that's very easy to handle. You just simply return this string except for the very last character, which is a dash. The last character will always be a dash. Just simply get rid of that last character. Or rather, aloha. Okay. Before you leave, this part is the really important part, okay? So please, this is the part that's going to give you the most pain, so it's worthwhile to listen to this part, okay? So here we have both vowels and double vowels. But how do you know if a vowel is going to be part of a vowel or a double vowel, right? Like in keiki. Here we have a single vowel, and here we have a double vowel. So what you want to do is basically have an if statement that works accordingly. If it's a consonant, great. Then check if it's a double vowel first. That's going to be a lot easier than checking if it's a single vowel, because if it's a single vowel, you might go ahead and go to the next vowel. So always check if it's a double vowel first. How do I know if something is a double vowel? What I would have to do is basically check this letter plus the letter right after it. Now, I highly, and I cannot stress this enough, highly recommend using a slice operation here, because slices cannot go out of bounds. Therefore, you don't have to worry about an out of bounds operation from looking ahead. Right? Use a slice to figure that out. Not only that, do not use a for loop, use a while loop to iterate over. Why? Because every time you're reading a syllable, you're reading either one or two letters. And you don't know how much that will be, so you have to manually control how much you're reading. Using this, you're going to have a much easier time to go through it. So check if it's a consonant. If it's not a consonant, ask if it's a double vowel. Otherwise, ask if it's a single vowel. Otherwise, there's very few other things it could be in that case, like an apostrophe. All right. Take care. Let's see what it says is wrong. Hold on. Let me stop the recording.